In this video, I'm going to show you how to identify the parts of a graph. The first thing you need to do is identify the type of graph that you're working with. You're going to do that by identifying the title on each axis. Here we have distance and here we have time. So we're working with a distance time graph. Distance, time. The next thing you're going to do is identify each axis. So here, going up and down, we have the Y axis. Going up and down is the Y axis, up and down. And then going across, we have the X axis. So we have the Y axis going up and down and the X axis going horizontally. All right. Now we're going to identify the intervals that are being used. The intervals simply count how the numbers are moving on each axis. Let's start with the Y-axis. Here we have the point of origin, which is 0 here, the point of origin, or the PO, point of origin. And then we have from the first number to the second, we have 0, then we have 2, 4, 6, 8, 10, 12, 14. So we're moving in increments of 2. That means from the first point to the second point, there's 2. From the second to the third point, there is 2. From the third to the fourth, there is 2. From the fourth to the fifth, there's 2. And on and so on. Now, let's look at the x-axis. So, here we have the point of origin, and then it's 0. Then we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we're moving in increments of 2. That means from the first point of origin to the second point, there's 2. From the second to the third, there's 2. From the third to the fourth, there's 2. From the fourth to the fifth, there's 2, and so on. So we're moving in increments of 2. Now let's identify what's happening on our distance time graph. So here we have our time in hours and our distance in kilometers, okay? From our point of origin, which is here, okay, to our second point where we stopped here, let's label that A, okay? From point of origin to point A, you're going to see a constant speed. And you can tell the speed is constant by doing a little trick. So from here, you can see where the lines intersect to see if it equals 1. So from here, at a distance of 2 kilometers, the time was 2 hours. So in 2 hours, they went 2 kilometers. 2 divided by 2 is 1, okay? In 4 hours, they went 4 kilometers. 4 divided by 4 is 1. In 6 hours, they went 6 kilometers. 6 divided by 6 is 1, and so on and so forth. If you do this entire line, you'll notice that it all equals 1 because they're traveling at a constant speed. Now, from point A to point B, this is going to be stationary or no movement. No movement. Okay? So imagine that you're in a car driving. You're driving at a constant speed, and then you get to a stoplight. You're at the stoplight and you're waiting for the light to change. You're not moving a distance, but the time is still moving. So this flat line represents the time moving, but there's no distance, no movement for the distance. There's no movement between point A and point B on this distance time graph. Now, from point B to point C, the line is going up again. So that's going to represent a constant speed. And just for fun, let's add an additional line. So from point C to point D, okay, this line is also going to show a constant speed. Okay, so the speed, although the speed is changing, it changed from this speed here at point C. It is constant as it goes down to D. So constant speed from point of origin to point A, no movement from point A to point B, constant speed from point B to point C, constant speed from point C to point D. That's a distance time graph.